at Loblaws. And I literally mean I have to be able to walk into Loblaws and walk out with enough stuff to make booze. Third process, this is where it gets really fun, is, as I was mentioning, the yeast is floating all around us in the air. I'm going to tap into that, and I'm going to use that yeast to make some booze with some of the Loblaw stuff. This is where it gets, I called it magic. That's actually a really bad name, because it's actually not magic, it's science. It just really feels like magic. So, alright, so this is a bit of a sneak glimpse of when we get to midway through the experiment. Part of why I'm doing it this way is because I can't actually run a fermentation workshop in half an hour at a bar. I just can't. So I figured I'd just do it at home and take lots of pictures and show them to you. So, okay, so I'm going to get started. Process here. So we're going to ferment each batch of juice by adding yeast. And then once each batch has fermented, like once all the sugar is burned off and turned into booze, we have to do 3 more things. We have to age them, which is where, aging makes it really taste good. It doesn't actually make it any boozier or different. It just makes it taste better. We have to get this juice out of that big fermenter into a nice portion-sized bottle that we can then drink from. Mic going up. And then finally we have to carbonate it, because apple cider should be carbonated. It tastes better that way. So, and my hypothesis, this is a bit of a lame hypothesis because I've done this thing so many times, but everything is going to work, and the resulting beverages must be drinkable. They cannot be disgusting. If they're disgusting, then this whole thing is useless. They have to taste good. They have to be enjoyable, and they have to be safe, so there can be no funky things floating around in them. Yep. And the airborne process that I went into at the end there is going to, I think it's going to be a little more unpredictable due to the fact that I'm just pulling yeast out of the air, but it's going to work. Popcorn says, let's get started! Alright. Okay, so we're going to start with the standard. This is a commercial brew process. This is how, or a standard home brew process. Commercial breweries are going to use much larger equipment than what I use here, because they're pushing through tons of the stuff. I'm pushing through 2 liters. It's the same thing. It really is the same thing in a much smaller scale. And because we're using this commercial process brew, we're going to allow ourselves to use proper brewing equipment. So this is what a typical brewery would look like. Lots of big things that probably hold lots of beer that's either bubbling or aging or whatever. This is what my brewery looks like. A little smaller. But at the end of the day, it's all the same stuff. There's your stuff that you're going to ferment. There's your fermenting container. This is my fancy yeast that I bought at the brew store. This is my airlock. As the stuff ferments, it lets off lots of gas. This lets the gas get out of the glass jug. And this over here is just a device that I use. This measures it measures the density of sugar in the drink. This lets me calculate how much alcohol is in there. I'm going to get back to that later. So how do we go about making a batch of regular old booze? We pour the apple juice into the container, pitch in the yeast, we seal the container with that airlock that I showed you, and we wait. Kind of all there is to it. So here I'm pouring the juice into the jug. Then I tear open that packet of yeast and I pour it all in. There's the juice with all the yeast, but then this is 30 seconds later. Before long, this will become some bubbling mass, and then I just stuck in that airlock. So that's really how you get the thing started, and then we just have to wait for it to all ferment. Do you have a question?
Airlock.
What's that?
What is the airlock about?
Okay, so what's happening is inside here, as it starts to ferment, remember how I mentioned that lots of carbon dioxide, lots of gases forming? What the airlock does is, as the carbon gas pushes out, there's a water barrier. So the gas inside the jug can get out as the pressure rises, but nothing can get in. It's just to prevent bugs and other things from getting into your booze. All right. So okay. So now we have to wait for the stuff to ferment. And different things take different amounts of time to ferment. Beer takes about a week. If you're making a regular old beer, it takes about a week to all bubble off. Wines and meads are a lot more across the board, but they typically take closer to a month. Cider happens very quickly. Cider happens in 2 to 4 days. That's probably why I wanted to use cider for this project, because it's really simple. This is a picture of it as it's almost done. You can see a few bubbles, but really, at this point here, it's actually almost done fermenting, so it's not really that good of a picture. Okay, so it's done. All the booze is formed. There's no more sugar left in there. So now we have to transfer the booze out of that dirty fermenter into a new container where we can age it. But I'm just not going to bother, because I don't see a point, really. It's fine. And then we have to so now that we have all of our fermented booze, we have to get it out of this messy fermentation jug and into nice, convenient portion-sized bottles. You can do that anyway. You can pour it through a funnel. It doesn't matter how you get it out. You just got to get it out. And when it's in those bottles, you have to carbonate it. And the way that I'm carbonating mine is I'm adding a tiny bit more sugar into the bottles. And what's happening there, the sugar is letting off more gas, and that gas is the carbonation. This is a DIY trick. If you have money, you buy a machine, and that blasts it full of carbonation. All right. So this is my siphon. I just did a siphon because it's just so you know. I got 3 bottles. Put down there, filling them out of here, and and then you go and have yourself a damn good time. Alright, so that there is a more standard, the more commercial, nice way of making booze. So this is where I move on to my more experimental stuff. This is where it gets really fun. So so this is the Loblaws process. This isn't one where you literally have to be able to walk into a Loblaws and buy everything you need to make drinks in that Loblaws. And when I say everything, I mean Loblaws ingredients and Loblaws equipment. So no airlocks, no fancy jugs, just stuff you can get at the store. And same thing for ingredients. None of that fancy yeast that I had that came in that little package. We're not using that anymore. So how do we dumb it down to the point where we're able to work with Loblaws stuff like this? So I've got my second jug of juice right here, and right here I have my bread yeast, whatever. It's yeast, same stuff, it works. Why not? It's fine. So we need yeast. The only suitable yeast is bread yeast, so we go and get some bread yeast, and we need a container to ferment the juice in. You remember how before we had that really nice gallon jug, and now we don't have that nice gallon jug anymore. And I mean, someone out there is probably thinking, why not just ferment the juice in the plastic bottle that it came in? And I think that's a freaking excellent idea. So we're going to do that. And now we need an airlock because we have to let all that gas out of the bottle. And so you could do a DIY hacker airlock. There's a billion different ways to do that. I'm not even going to go that way. I'm just going to. What I'm going to do here is I'm actually just going to seal the bottle and let it ferment in a sealed bottle. So all the gas is actually going to build up inside the bottle instead of being released. And then once you got that all done, you add your 1 teaspoon of yeast and you seal the bottle tightly. So this is my bread yeast. This is my bottle of juice right here. And that's the bottle with the yeast in it. That's all. And then you wait. You just put it next to a radiator and you let it start to ferment. If you're thinking this is really, really gross and foul, it's actually not. Admittedly, it tastes a bit bready, but it's fine.
We're thinking about the Halifax explosion. What we're thinking about.
I'm going to talk a lot more about that later. The Halifax explosion factors into the presentation, but I'm going to cover that in part 6. But as you mentioned, as the juice ferments, the bottle becomes intensely pressurized with carbon dioxide gas. So what you have to do is you have to monitor that bottle closely, and whenever the bottle gets really, really insanely pressurized, you got to grab the cap and let some of that pressure off. And it takes about 3 or 4 days until, after about 3 or 4 days, you'll know if it really isn't pressurizing much. And whenever you turn out the cap, it just kind of goes, and then it's done. But this is, you notice right here, this is the bottle. This is the bottle as it's like that's fully pressurized compared to the bottle that's not pressurized. So you'll notice it's taken on a bit of a cylindrical form. And just to give you an idea, it's so pressurized you can't just pop off the cap. You have to do it multiple times. I think because the juice freaking flies out of the thing. But I mean these bottles are fine. They typically work fine. And anyway, so then it comes to racking and aging, because like I said, we want to age it, but I'm not going to bother again because bum. And then we have to deal with bottling and conditioning. So this is really convenient because the juice is already in a bottle. And what's even better about this is you know how I was threatening the London or the Halifax explosion by keeping all that gas in the bottle. What's actually happened is that gas has carbonated the drink. So, alright, so that is the Loblaw process, and if you don't believe me, go and fucking try it. And it works, and it tastes good, and the LCBO might be going out of business thanks to me. So now I'm going to talk about the air. So this is my last process. I'm going to talk about the airborne process, almost the same as the Loblaw process, but this time I'm not going to use that bread yeast. I'm going to work exclusively with airborne yeast. So, and this is actually very important for this process. As I was saying, yeast needs to be at a certain temperature to ferment. With the previous two, it works just fine at room temperature. With this one here, it has to be at 25 to 30 degrees Celsius. So you can really only do it in the summer. I've been working with it in the winter, and you can do it, but it's not the same. So really, you have to have a lot of ambient heat to make this work. So this is it. It's all that we're using. We're just going to take that. And so what we do is we take that bottle, and we need to get some yeast in there, so we take the cap off. The next thing that we need to do is so we've got a bit of yeast in there, but we should get some more. And so what I'm going to do is I'm going to shake the piss out of that bottle, distribute the yeast in the thing, and then I'm going to just repeat this procedure a few times. To be totally honest, I do not even know if repetition is necessary, because this past summer, remember how it was really hot? Like really, really hot? You could literally open a bottle of fruit juice and close it and the thing would ferment. And I know this for a fact because it happened to me many times. So this is my bottle after I've let in a bunch of air and shaken it. Looks just like a bottle. I know this seems ridiculous. You're thinking, how is this going to turn into booze? That is going to turn into booze. Within a few days, it will start to ferment. And once the fermentation kicks in, once again, pressure builds up, and you got to start releasing the pressure manually. And after another 3 to 7 days, it takes a bit longer because it's just dealing with ambient wild yeast. And once again, no need to rack it. We're not going to bother with racking. We're not going to bother with bottling. We're just going to pour ourselves a drink of fermented booze. So you're probably wondering, how do I know if this actually worked? Like, am I just making all this shit up? So what I did is that little thermometer thing that I showed in the previous slide, that measures how much sugar is in the juice, and